Hello, my name is Robert Anderson, and I'm very proud to be part of a team that has produced a GUI interface that allows users to access and harness GBIF information. One of the most important uses of GBIF data is to model species niches and potential distributional areas, which have been used tremendously in basic and applied environmental biology. Two of the major obstacles that hinder such models are biased sampling across geography and our ability to quantify model performance and estimate optimal model complexity. Recently, we were part of groups that produced two R packages that automate solutions to these problems. In this submission to the Nielsen Challenge, we have produced a GUI that allows a broader set of users to build and evaluate niche models using GBIF data.
I'm Jamie Cass, the lead developer. We implemented our submission using Shiny, which is an R package that allows you to develop web applications and local GUI interfaces that run R in the background and allow users to click and explore without having to code themselves. The way our international team was able to work seamlessly together was through GitHub. We've named our application Wallace, and it can be run on the web or locally through RStudio on either Mac or PC.
My name is Matthew Aiello-Lammens, and I'm one of the Wallace developers. Wallace is set up with tabs separating the major functions. I'm going to step through how to obtain the input data to build our models. We use our GBIF to pull occurrences from the GBIF database. In this example, we're going to pull occurrences for the species Tremarctos ornatus, the spectacled bear, which is found in cloud forests of the northern Andes. When we first see our data, we notice that there are outliers. We can remove these outliers by first identifying the point, in this case ID 27, and then entering the number here and removing it. After removing all the major outliers, we then want to reduce the effect of bias sampling across geography. To do this, we're going to use the spthin R package. In this package, we set a thinning distance, which is a biologically reasonable distance by which we expect the occurrences to be separated. In this case, we're going to use 20 kilometers. We run spthin, and see we have a less clumped set of occurrences. The next step is to get our environmental variables. Currently we offer the WorldClim environmental variables at various resolutions. We're going to use 2.5 arc minutes. We're going to select our study region as the minimum convex polygon of our occurrences with a 1 degree buffer.
Hi, this is Jamie again. To build and evaluate niche models, we use the R package ENM-eval. Currently, ENM-eval only allows users to run models in Maxent. We can select different feature classes to adjust the flexibility of the model response. We can also test a range of regularization multipliers that penalize model complexity. For this demonstration, we will be using feature classes linear, linear quadratic, and hinge, and we will be testing a range of regularization multipliers from 1 to 3 with a step value of 0.5. Lastly, we will be cross-validating our models using the block partitioning method. ENM-eval returns a table with various evaluation statistics, as well as plots, which assist the user in selecting optimal model settings. Here, on the View Predictions tab, we will look at one of the high-performing models, Hinge 3. This model, based only on climate, does a nice job identifying wet montane forests, but it's important to note that it does not take into account deforestation.
The field of niche and distributional modeling is moving forward very quickly. That's one of the reasons we designed Wallace to be modular and expandable, hoping that would encourage others to add their R packages in the future. We've also realized that this approach of combining R packages for a given topic might be emulated by other fields, such as phylogenetics. Thank you for your consideration of our submission to the Nielsen Challenge.